So we have a multi-threaded program with two threads, T0 and T1. And each of those threads is supposed to update the variable a. Its value is 3. So if both threads update it, we expect to get 5. However, does that necessarily happen? Let's try and figure that out. So T0 loads the value from memory into a register. Okay? T1 does the exact same thing. Meanwhile, T0 is updating that value. So we get 4. And T0 immediately stores that into memory. So we have 4 there. However, T1 can happily continue updating its register value, which is now also 4, which gets stored into memory and just overrides the 4 that's already there. So we get a result which we didn't expect and which is essentially not correct. So the scenario we had was a load by T0, a load by T1, a store by T0, followed by a store by T1. Okay, however, a different scenario could have played out. There could have been a load by T0, immediately followed by a store, followed by a load, and again a store by T1. So basically, this store would have written 4 to memory, which would have been loaded into T1's register, updated to 5, stored in RAM. So this scenario would have given the correct result. And of course, there is a complement to that. We could have load by T1, store by T1, followed by load T0, store T0. Again, correct. And of course, another scenario, the fourth one. We've got a load by T1, a load by T0, a store by T1, and a store by T0. Again, a wrong scenario. So this would be the wrong ones, these would be the right ones, and we would have a 50% chance of getting the expected result. That would depend on the order of execution of the operations, and that is exactly what a race condition is.